Hello guys, welcome to Learning and Living channel. So according to our study plan, we have our topic as data structures, and in data structures we have as arrays, stacks, queues and linked list. But before that, first we'll know what do we mean by data structures. So first we'll know what is the definition of data structures. So what is a data structure? So basically, a data structure is a way of storing and managing the data so that data can be accessed and utilized efficiently. We have two types of data structures, that is linear data structure and non-linear data structure. Like the classification of data structures is based on the arrangement of the data, that is called as linear and non-linear data structure. So based on linear data structure is for example arrays, stacks, queues and linked list come into linear, while non-linear is it is not ordered, that is tree, graph, heap, AVL, hash table come under non-linear. So we'll go through this one by one, but before that, why do we need data structures at all? So first let us understand why do we need data structures. Like for example, just consider an example. There is a ticket counter, like everyone is standing in queue. Whoever comes first will be given the ticket first. That is like uh, whoever comes first, that is they'll go out first, that is first in first out. And if there is and let us take another example, like there is a plates which are one above the other, we keep one above the other, but we'll take the upper one first, that is it follows whatever goes last, that is taken out first, that is last in first out. Like based on our requirement, we follow the different type, we use a different type of manner. Similarly, in coding or that way, in to make our things easier, we follow an algorithm. Like for different inputs, like based on our input, to get our output fast, we use different algorithm for a different problem. So the result, we get it with minimum efforts and we'll get it efficiently. So our data structures is important. Like as we mentioned in our previous example, uh, the ticket counter queue is follows last in first out, while stack follows first. Queue follows first in first out, and stack, that is the stack of plates, follows last in first out. Similarly, the algorithm differs for different problem. Uh, we want data structures for this use case. So to make our work easier, we implement different data structures which are needed, whether it's linear or non-linear. So until now we have seen about the what is the definition of data structure, what are the different types, that is non-linear and linear, and then why do we need data structures to make our problems easier and to complete them in a minimum effort. We use the data structures. Similarly, but how can these algorithms be measured? These algorithms can be measured by time complexity and space complexity. But what do we mean by time complexity and space complexity? So, time complexity is the amount of time taken by our algorithm to complete the takes to complete based on our input size is called as time complexity. Let's repeat it again. The amount of time taken by an algorithm for a based on the input size is called as time complexity. Similarly, space complexity is the amount of memory that requires during execution as input size increases. This is called as time complexity and say space complexity. Let us take an example. There is a for loop which iterates over I equal to 1 to I less than n, and I is incremented every iteration, and we will print our I. Okay, just understand, I'm just writing it this way. So similarly, just take our input n is equal to uh, 2 as our iteration, like initialized I as 1 will take n equal to 2. When n is equal to 2, that is input size equal to 2, and the output becomes 1 is less than 2, so we'll print I, that is 1 is printed. When n equal to 3, the output becomes 1 is less than 3, so 1, and 2 is less than 3, so 2. 1 and 2 gets printed. Similarly, for when we have it as 10, it starts with 1, 2, 3, and it goes on till 9. So as we can observe, when our input is increasing, the like for executing this, it takes only just take an example as 1 millisecond. It might not take 1 millisecond, but let us consider it as 1 millisecond. For this it might take 1 millisecond, for it might take 2 milliseconds, for this it might take 10 milliseconds. Similarly, when we can note it as this is the uh, input on x-axis and our time on y-axis. As the input is increasing 1, 2, 3, 4, our time is also increasing. So it is moving like this. This is always increasing. So our time complexity is depending on our input size. That is the reason we said our definition of time complexity as the amount of time an algorithm takes to complete based on our input size is called as time complexity. I hope you understood. Uh, so this is what we understood, like about why do we need data structures, and how these algorithms are can be analyzed. That is analysis of algorithm, that is time complexity and space complexity. And we have different types of time complexities, such as order of 1, which is constant, and order of logarithmic, that is order of log n, and order of n, order of n log n. Similarly, we have many such, and there is a priority for them as well, like which one is small and which one has the highest priority. So until now we have seen the definition of data structures. Let's recap it fastly. So first we have seen the definition of data structures. That is, a data structure is a way of organizing and storing the data in a computer, so it can be modified and accessed efficiently. And then we have types of data structures as linear and non-linear data structure. Then when we understand the types, we could just know, but why do we need data structures? To complete our tasks in a minimal effort, based on our input and our output, we use the different type of data structure, and that is called as an in the inside we use an algorithm. But which type of algorithm and how can these algorithms be classified, that we have seen by analysis of algorithms, that is by using the time complexity and space complexity. And then we understood about time complexity and space complexity. So uh, yes, and then we have understood what are the types of time complexities. So until here we have done about data basics of data structures. And then we'll go into next we'll go into searching techniques before going to our linear data structure. So the searching techniques, basically the when we have an array, you can see this is an array. In an array, searching can be done using linear search, or binary search. And so a linear search is checking for that element, whether it's present in our array, by checking for each and every element, as you can see here, by checking for each and every element. And if the element is equal, then we'll return that. This is called as linear search, but this takes almost, the worst case complexity will become order of n, like the n is the size of the array. It takes, like, whatever input size we have, that uh, time complexity it takes, that is our worst case complexity. Similarly for now we'll check for binary search. The important thing for binary search is the array should be sorted when we are going to apply our binary search. For binary search, first we take the lower and higher, then find out our middle element. Here we have 0 plus 9 by 2 is 4.5, so we take the base, that is 4, and for 4 the index, the element is 16. Now we are going to search for 23 element. So first we'll check whether 16 is smaller or greater than 23. 16 is smaller, so we'll increment our lower to next of middle, that is fifth, equal to 5. Now again we'll check for middle. When we check for middle, that is 5 plus 9, 14 by 2 is 7. Again check, that is at index 7 we have 56. 56 is less than or greater than 23. 56 is greater, so we'll again reduce our highest point to 6, and we'll check the middle value, and then we'll check if 23 is equal to 23. If there is no number available, then we'll return -1, and if we find our number, we return the index of that element. These are both searching and linear search and binary search techniques. So let's get into our main topic, that is this is a searching technique, like whatever we have discussed, that is included here. Oh yes, I forgot to talk about the or time complexity here. Here it is order of log n, because we are not checking for the whole array. We are first checking the middle, and then we'll be checking only the next half. So this is a best approach. This follows order of log n time complexity. Time complexity, like you can refer the notes here. I've included all the theory part here, and the explanation has been already done. You can take a screenshot of this. And next comes is our arrays topic. So basically, what do you mean by arrays? So arrays is a linear data structure that stores homogeneous elements. Homogeneous elements is nothing but whether it's of a same data type, int, float, decimal, anything of the same data type is called as homogeneous elements. And what do we mean by contiguous memory location? For example, the index 0 address is mentioned as 0. Then for when we are using the int data type, the second element address becomes 100 plus 4, that is 104. Like for int the size is 4, so similarly it goes to 108, 112, and so on. So first we have understood what does array look like. It starts with index 0 and increments. Like the size of an array should be initialized at the start, before itself. And then there we have different types of arrays, that as 1D array, 2D array, and multidimensional array. And there are many operations that can be performed. Like we can traverse through our array, like checking for the all elements. We can search for an element, like we can search for 15 in our array by using indexing. And then deletion of a specific element, deletion from first, deletion from last, insertion at first, insertion at last, inserting at a specific position, updating or sorting. All operations can be performed. And type complexities, this is important for array. Like, and even the address calculation, like generally in previous questions I observed that a question, like a 3 by 3 matrix is given, where we need to find the what might be the address when a base address is given. And then coming to time complexities, as we have discussed about binary search and linear search, it follows order of n and order of log n. Making note that binary search has sorted array, insertion and deletion. Yes, these are just the notes which you can access, and this is the concept which we have covered. The main things are definition, how the array is represented, like it is in a contiguous memory location, and there are different types of array: 1D array, 2D array, and multidimensional array. What operations can be performed, its time complexities, sorting and searching techniques. Sorting techniques, will go through it again. And advantages is fast random access. Yes, disadvantage also important here, as it has only fixed size. Like the insertion and deletion becomes costly. Like for example, if you want to if the array tells only for 10 elements can be inserted, and when we want to insert more than 10 elements, it becomes an issue. And here we get here linked list comes into picture. Like this disadvantage is not seen in the linked list. Like in now let us learn about linked list. Linked list is a linear data structure which stores the data in the form of data and the uh, pointer. That means here this is data and this is the pointer. Pointer means it stores the address of the next node, uh, is called as a linked list. So this is all a chain. This does not have any index. And uh, and we have different types of linked lists, such as single linked list, double linked list, circular linked list. And the double linked list, we have uh, previous, this is called as previous, and this is the next. Previous stores the address of the previous element, and next stores the address of the next element. And coming to circular linked list, the last node, where here we do not have anything, but in the circular linked list the last node is connected to the head itself. This makes our circular linked list. And yes, the time complexities is also important. So inserting complexities at beginning is order of 1, because we need not search for anything. So insertion happens easily, order of 1, order of 1. And that is constant time complexity. And at end we have to traverse through each and element, check for our tail, and insert it. That is order of n for both the insertion and deletion. And search complexity is also order of n, because we will traverse through each and every element. Here we have as we have seen that in arrays we are facing a problem like static array size. Here that has been like dynamic size. So So let's continue. Our topic is stack, that is last in first out. It is a linear data structures that follows last in first out. Like for example, we first it's like uh it's like our it's like plates. We put first one plate, two plate, three plate, and four, and then we take out one after the other from the top. So it the whatever the last that is inserted is the first element that is being removed. This is the principle of our stack, and the operations include push, pop, tweak, is empty, and is full. Push is nothing but an element. When we push an element into our like when we insert an element into our stack, it is called as push. When we delete an element, it's called pop. Mm. And if uh, check whatever the element that is at the top, to get that is called as peak, and is empty is to check if the stack is empty, and is full is to check if the stack is full. If the stack is empty but we still try to pop an element, then an underflow underflow condition occurs. And when the stack is full and when we try to insert an element, then an overflow condition will occur. This is all about stack. And fast insertion and deletion at the top, it's a simple implementation. Stack can be implemented using two approaches, using arrays and linked list implementation. Stacks and queues are important for our examination. And coming to queue, queue is a linear data structure that follows first in first out. As we have seen in the ticket counter, whoever comes first, their priority is given to the one who comes first. That is the principle of our queue. And operations performed here are Enqueue and Enqueue, Dequeue, front, rear, is empty and is full. Enqueue is the process of inserting an element into an queue is called as enqueue, and an element deleting is called as dequeue. This is done. Dequeue is performed at front side, while enqueue is performed at rear side. Queue contains front and rear positions, while our stack contains uh, uh, top, what element is present at the top. Uh, Now coming to queue, this can be implemented using arrays as well as linked lists. And there are different types of queues such as linear queue, circular queue, priority queue, and dequeue. Dequeue is nothing but double-ended queue. On both sides, insertion and deletions can be performed. And coming to time complexity, in Enqueue is order of 1 because insertion happens at the rear side, and Dequeue is also order of 1 because the insertion deletion always takes from the front side, and these are the time complexities. Um, when we are implementing using an array, we have a fixed size. So when the implementation, when the array size is full with elements and we try to enqueue it, then an overflow condition occurs. And when the elements are not present and we try to dequeue the elements, then the underflow condition occurs, similar to the stack. And advantage is it is efficient processing and arrival order. One important one interesting thing is to use the space complexity. Like when 3 and 4 goes out, these spaces get empty. So to make it efficient, a circular queue can be implemented. Like when 3 4 are pushed out, popped out, that is dequeued, then these two can be implemented if we are using a circular queue. And application sequence scheduling, printer queue, ticket preservation, BFS, producer, consumer problem, and applications are also important here. So until now we have seen about arrays, linked list, stack, and queue. Arrays, it is a linear data structures that stores the elements that store homogeneous elements in a contiguous memory locations. A linked list is a linear data structure that stores the elements in a node and pointer format, that is the address of the next node inside the pointer. And stack is a linear data structure that follows LIFO, that is last and first out, while queue is a linear data structure that follows first and first out. Mm, So these stack and queue can be implemented using arrays and linked list. And coming to stack, this contains operations such as push, pop, peek, is full, and it's empty, while queue follows dequeue, enqueue, peek, front, peek, rear, is empty, and is full. So this is all about stack, queue, arrays, and linked list. Is solving many practice questions is also important for our HL design trainee, or whether it's management trainee as well. Um, so until in the whole video, we have talked about our definition of data structures, what are the different types of data structures, and searching and sorting techniques, by data structure, analysis of algorithms, that is time complexity, space complexity, types of complexities, and linear data structures. We have talked about 4 linear data structures, and also coming to questions. I hope it's visible. Gate overflow Gate overflow for topic wise quiz and previous questions of gate, like all the 1 mark questions, because mostly these are asked in our exam. So gate overflow is the best, as I have also referred them. Thank you for watching. Do share and subscribe if you like, and you're also practicing. You can comment down so that we can learn together. Thank you.